Good morning students. Thank you very much students for clicking on my video. I am your Nagini ma'am, chemistry mentor. In today's section I am going to discuss about the extraction of iron from hematite ore students. Blast furnace diagram. This is the topic from General Principles and Processes of Isolation of Elements 12th class 2nd PUC topic. Okay now. So here first what are the methods involved in the extraction of iron from hematite ore? So one by one we are going to discuss students. So first method is concentration of the ore. What is the concentration of the ore students? Concentration of the ore means it is a process of removal of impurities from the ore. Are you clear? So removal of impurities from the ore. So that is nothing but concentration of the ore. So first we have to remove the impurities present in the hematite ore. Understanding? So that's why we are doing concentration of the ore. Concentration method we are doing. Here in the concentration, which method is using students for the to removal of impurities students? Gravity separation method is using students. Okay nama. So concentration, it is concentrated by concentration method. First it is concentrated by gravity separation method. Clear? Gravity separation method students. So in the gravity separation method students, what we are doing nana in gravity separation method? Here what is the ore particles are there? That ore particles first we have to disturb that ore particles with water students. So that means in this process the powder ore is agitated with the stream of water nana. Okay now, with the stream of water, then what will happen students? What are the heavier ore particles are there? Those particles are settled down due to the force of gravity. And what are the lighter weight particles, impurities are there? Those are those particles are washed away with the excess of water students. That is a gravity separation method. Now I am not going to discuss about that method. Okay now. So by the gravity separation method, here what are the impurities are present in the ore that we have to remove students? Are you clear? Clear this one? Gravity separation method. Here nothing is there students, just you have to just by forcefully whenever water is passing through the powdered ore students, what will happen? The powdered ore is agitated, that means it is disturbed. Okay now, then in the powdered ore, what are the ore particles are there? Heavier weight particles, those are settled down. Lighter weight particles are impurities, those are washed away students. That is the concentration of the ore. Are you clear students? This is the concentration of the ore nana. So after concentration, here we have to remove the impurities from the hematite ore. So impurities are removed, concentration of the ore, this method is completed. Next, second method is what doing students? Calcination. Second method is calcination. So what is calcination students? What is calcination nana? It is a process of it is the heating process students below its melting point. Process of heating the ore below its melting point in the absence of air, correct? So here what we are doing, this the concentrated ore. Here the ore is concentrated because here what are the impurities are there? Removed nana. Lighter weight impurities are all are removed. So that ore will call it as, the resultant ore will call it as, that is concentrated ore. So now we are taking the concentrated ore. The concentrated ore is heated in the absence of air. Here see students, calcination. In the calcination method, the concentrated ore concentrated ore is heated in the absence of air. Are you clear? In the absence of air, by heating, what will happen students? Here still what are the impurities are there? Those impurities are also removed students. So that means what type of impurities? By the calcination method, any moisture or volatile impurities are present, those impurities also we can remove students. Are you clear? So by the calcination method students, moisture and volatile impurities are removed. Okay nama, moisture and volatile impurities are removed. Volatile impurities are removed. Clear this, students? So by the calcination method, students, we can remove the moisture and volatile impurities, students. Are you clear? These impurities are removed, Nana. Next method is roasting, students. What is the roasting method? Now see, Nana, roasting method. Third method, roasting. So in the calcination method, the ore is here. In the calcination, some what are the volatile impurities are all are removed, na moisture. So the resultant ore is calling as calcined ore. Are you clear? So that calcined ore we have to take. Are you clear, Nana? So the calcined ore is heated. The roasting is nothing but it is also process of heating the ore in the presence of air. Calcination is nothing but in the absence of air. This is the presence of air heating. Okay, Namma? So here the resultant ore after removed impurities in the calcination method, this result the resultant ore is calling as calcined ore. So that we have to take the calcined ore is heated strongly in air. Okay, is heated strongly in air, Nana. Okay, now so then what will happen, students? What is the ferrous oxide is present in the hematite ore? It is converted to ferric oxide. Okay, now so that means FeO is converted into Fe2O3, Nana. FeO. So I am taking the reaction. See here. Here what will happen, students? Ferrous oxide, okay, ferrous oxide convert into ferric oxide, Fe2O3, students. Now see here equation, Nana. FeO combined with half moles of O2 produces Fe2O3. Fe2O3. Take here 2 moles, then equation is balanced. Okay, now that means ferrous oxide is converted into Fe2O3. That means ferric oxide. It is converted into ferric oxide, students. Understood, Amma? So this is the roasting method. So in the roasting method, ferrous oxide is converted into ferric oxide. Okay, ferric oxide is formed in the roasting method. Now next method is smelting, students. What is the next method, Nana? Smelting. And now see, students, is the smelting method. This is the fourth method, Nana. In smelting method, what doing, students? In the last method, roasting method, the ore is roasted. That means iron oxide is converted into ferric oxide, correct? So that then what will happen, students? The ore will become roasted ore. So that's why we are using the word the roasted ore. Clear this one. The resultant ore is calling as roasted ore. Are you clear, students? After concentration process, the resultant ore is calling as concentrated ore. After calcination process, the resultant ore is calling as calcined ore. After roasting method, the resultant ore is calling as roasted ore. Are you clear? So that roasted ore you have to take. The roasted ore is mixed with the roasted ore is mixed with limestone and coke. Mixed with limestone and coke, Nana. In the ratio, students, the roasted ore is in the ratio 8, limestone ratio 1, and coke ratio 4, students. Are you clear? So 8 is to 1 is to 4 ratio. In this ratio we have to take, Nana. This mixture is calling as a charge. What we will call charge. Understood, Amma? So what is the charge, students? The mixture of the ore, and limestone and coke. This mixture 8 is to 1 is to 4 parts. 8 parts ore, 1 part limestone, and 4 parts coke you are taking. This mixture is calling as charge, students. Are you clear? So now this charge here we have to introduce into the blast furnace, students. Okay, Namma? This charge we have to introduce it into the blast furnace, students. You have to introduce into the blast furnace. Clear this one? Blast furnace. So now a blast of hot air is sent upwards through the tires, students. Here when a hot air is passing through the tires, Nana, upwards. Here see, students, I will show you the diagram. See here. So in this diagram, what I told you, Nana, see here, hot air, these are the tires, Nana. Okay, so this is a blast furnace diagram. See in this diagram, this is the cup and cone arrangement. So here we are passing the charge. Charge is nothing but we know that what is the charge? Ore plus limestone plus coke. That charge we have to pass into the cup and cone arrangement and introduce it into the blast furnace. This one. Okay, now here we are passing the hot air, students. Here there are two inlets. Hot air is passing into the blast furnace through the tires. These are the tire, students. Are you clear? Through the tires. Hot air is passing through the tires into the blast furnace. Here how much temperature range will be there, students? 1600 to 250 degrees Celsius temperature range will be there from bottom to top. From bottom to top, this much temperature range will be there. In this blast furnace, there are 4 different zones will be there. In each zone, what are the reactions are taking place, that all I am going to discuss now. Okay, Nama. Now see, students, here one zone I will discuss in the diagram, students, then you can easily understand. Okay, ma. Okay, now what we are discussing, students? Hot air, right? When hot air is sent, hot air hot air is passing into the blast furnace through the tires. Okay, when hot air, now we are passing hot air. So hot air is sent upward through the tires, through the tires. Clear, students? Through the tires hot air is passing, Nana. Okay, now what is the temperature range, students? Here temperature range 1600 to 250 degrees Celsius. Are you clear? This much temperature range will be there, Nana. Okay, Nama. This temperature range is 1600 to 250 degrees Celsius from bottom to top. From bottom to top. Are you clear? Bottom to top. Now what we are doing, students? Here in the blast furnace, students, there are 4 different zones. What are the different zones, students? First one is the combustion zone. Okay, na ma'am. So blast furnace, in the blast furnace, students, there are 4 different zones, Nana. Blast furnace, how many zones are there, students? In the blast furnace, 4 different zones are there. It contains 4 different zones. Okay, so first zone is combustion zone. Okay, combustion zone. Next, second one is reduction zone. Third one is slag formation zone. And fourth one is melting zone. Are you clear? Total 4 types of zones are there. So first one by one we'll discuss, students. What is the combustion zone? Now first one, combustion zone. In combustion zone, what will happen, students? In combustion zone, so combustion zone is the lowest part of the furnace, students. It is the lowest part. It is the lowest part of the furnace. Okay, here temperature range, students, here temperature range 1500 to 1600 degrees Celsius will be there. Okay, it is the lowest part of the furnace. Now see, students, in the diagram, Nana, it is the lowest part of the furnace. See here. So in this diagram, Nana, see here, this is the lowest part. This is the blast furnace diagram. Here in the lowest part, here temperature range is starting 1600 to 250 degrees Celsius. This is the lowest part. This zone is calling as combustion zone. Are you clear? This is the combustion zone, students. This is the lowest part of the furnace. Are you clear? This is the lowest part of the furnace. Okay, ma. So this is the combustion zone. Okay, now see, students, Combustion zone. In combustion zone, what are the reactions are taking place? Combustion zone. Now see here, in charge, what we added, students? In charge, what is the mixture of charge? 8 is to 1 is to 4, limestone, coke, metal and roasted ore. Correct? So here coke is there, nama. So this coke, it is reacting, nana, in combustion zone. Okay na, so coke is combined with oxygen. Okay na, so that means it is react with air, hot air. So that means here what are the reactions are taking place, students? Carbon combined with oxygen produces CO2, nana, produces CO2. So this CO2 gas, nana, okay na, it is CO2, carbon dioxide, it rises upwards, and it is reduced to carbon monoxide, students. Okay na, this CO2 gas, in the which zone it is formed? Combustion zone. CO2 gas is formed. This CO2 gas is slowly, the CO2 gas is slowly moving upwards. Here this is CO2, here CO2 gas is formed. The CO2 gas is rises upwards. When it is rises upwards, what will happen? The CO2 is reduced to CO, carbon monoxide. Are you clear? So that's why here CO2, here they write that sentence, students. CO2, carbon dioxide rises upwards. CO2 rises upwards. What will happen, students? When it rises upwards, it is reduced to, it is reduced to CO. Are you clear? Carbon monoxide. So that means here carbon dioxide, when it is rises upwards in the furnace, what will happen? It is combined with coke and produces CO. That means it is reduced to CO, students. 2 moles of CO. That means here carbon is acting as a reducing agent. Coke, it can reduce the CO2 into CO, students. This is the combustion zone. So in the combustion zone is which one, students? It is the lowest part of the furnace. Here temperature range is this one. In the temperature, in this combustion zone, coke is combined with oxygen, produces CO. That means in the presence of hot air, carbon undergoes oxidation, produces CO2, students. And it is when it is rises upwards, what will happen? It is reduced to CO. This is the combustion zone completed. Now we are going to discuss about the reduction zone. Okay, Namma. So reduction zone. What is the reduction zone? See here. Next one, second zone. Reduction zone. What is the reduction zone, students? It is the uppermost part of the furnace, students. First one, combustion zone. It is the lowest part of the furnace. It is the uppermost part of the furnace, students. It is the uppermost part of the uppermost part of the furnace. Clear? Here temperature range, how much will be there, students? Temperature range 250 degrees Celsius to 700 degrees Celsius. Okay, the temperature range is 250 degrees Celsius to 700 degrees Celsius, Nana. Are you clear? This is the reduction zone. So in the reduction zone, what is happening, students? In the reduction zone, here limestone, in the charge we added charge. What is the mixture of charge, students? Ore plus limestone plus coke. So coke in the combustion zone, coke combined with oxygen produces CO2 and it is reduced to CO. It is completed. In the reduction zone, what is happening, students? In the reduction zone, what are the reactions? In the roasted ore method, students, in the roasted ore method, ferrous oxide is converted into ferric oxide. It is reduced to ferric oxide. Correct? In the reduction zone, I discussed you. In the reduction zone, what happened? This ferrous oxide is converted into ferric oxide. Correct? In the roasting method. Okay, now. So this ferric oxide combined with the CO, students. In the combustion zone, CO is formed now. So that ferric oxide combined with the CO. Now see, students, what are the reactions are taking place here? Fe2O3 combined with CO. Fe2O3 combined with CO, students, produces FeO, 2 moles of FeO plus CO2 gas is released. Are you clear? So equation is balanced. First ferric oxide is converted into ferrous oxide. Now this ferrous oxide, that means in the reduction zone what is happening means iron metallic oxides are reduced to metal, students. Are you clear? So in the reduction zone, students, what will happen? Metal oxide is reduced to metal. So that is the main thing here. Metal oxide is reduced to metal oxide. In this reduction zone, metal oxide is reduced to metal. Clear? Reduced to metal. Reduced to metal. So that's a here first ferric oxide is converted into iron oxide, ferrous oxide, and this ferrous oxide, here reaction seen on a ferrous oxide FeO, it is combined with again CO carbon monoxide, produces metal. Iron plus CO2 gas is released. This iron will call it as what we will call, students, spongy iron. This is calling as spongy iron. Okay na? So it is the uppermost part. What is the reduction zone, students? Uppermost part of the furnace. Here temperature range is 250 to 700 degrees Celsius. Now see, students, in the diagram, this is the reduction zone. Are you clear? This is reduction zone is nothing but it is uppermost part of the zone. That means 250 to 700 degrees Celsius. Still here, this zone is calling as reduction zone. Clear? It is uppermost part of the zone, the uppermost part of the furnace. Here Nana, this is the lowest part of the furnace. Which one, students? Combustion zone. Okay na? Combustion zone completed, reduction zone completed. Now we are going to discuss the third zone. Is which one, students? Slag formation zone. Clear? Third one is slag formation zone. Now we are going to discuss the slag formation zone. Third one, slag formation zone. Slag formation zone. So what about slag formation zone, students? Here it is the center, it is the center part of the central zone, students. That is the center part of the furnace. It is the central zone, or we'll call it as center part of the furnace. Center part of the furnace, students. Here temperature range nana, how much will be there, students? Here 700 degrees Celsius up to here, from 800 to 1000 degrees Celsius will be there, nana. 800 degrees Celsius to 1000 degrees Celsius. So this is the temperature range in the case of slag formation zone. So we know that what is the slag, students? Flux plus gangue combined, both are produces slag, correct? So that is the gangue means impurity. Unwanted impurities are calling as gangue particles. And what is a flux, students? Flux, what do we? Flux is used to remove the impurities. That means it is used to remove the gangue particles you are adding. Okay, so that is the flux. So here slag formation zone. What is the slag formation zone? It is the center part of the furnace, students. See here in the diagram, students, in the slag formation zone, this is the combustion zone, this is the reduction zone. Here center part of the furnace, what will happen, students? Center part of the furnace is the, understood amma? So this is the lowest part of the furnace is calling as combustion zone. Uppermost part of the furnace is calling as, this is the reduction zone. Center part of the zone is calling as, it is a slag formation zone. Are you clear? Slag formation zone, students. This is the center part. Are you understanding, students? It is the center part. It is calling as slag formation zone. So now we are going to discuss about the slag formation zone, students. Now see here, slag formation zone. Slag formation zone. Here we used in the charge, nana. What is a mixture of charge, nana? Metallic ore. So that is ore plus limestone plus coke. Correct? Limestone plus coke. Now here limestone you are taking, nana. In the slag formation zone, limestone CaCO3, it is present in the charge, na, it is decomposes. So that means calcium carbonate, it dissociates into CaO plus CO2, students. Are you clear? Slag formation zone, this limestone it is dissociates into CaO and CO2, students. Here at what temperature it is dissociates, nana? At 1000 degrees Celsius, nana, it dissociates into CaO and CO2. Okay na? Now this CaO combined with the CaO is acting as a here acting as a flux, nana. When it is combined with impurity, that is gangue particle silica, it is present in the ore. Are you clear? It is present in the hematite ore, students. Silica is a gangue particle, it is a impurity. So to remove this gangue particle, we are using the flux, students, CaO. Here CaO is acting as a flux, it is a gangue particle, produces calcium silicate, CaSiO3. Are you clear? Calcium silicate is formed. So here this one is which one, students? Calcium oxide is acting as a flux, silica is acting as a gangue particle, and CaSiO3 is acting as a which one, students? It is a slag. Okay, so here slag particles, students, here CaSiO3. These slag particles are lighter weight particles, students. Are you clear? So slag is a lighter weight particles. Okay, afterwards we can remove that. So this is the slag formation zone, students. It is the center part of the furnace. Temperature range is this much. This is the reaction. Here limestone is dissociated at 1000 degrees Celsius temperature. Slag is formed. Okay, now we are going to discuss the fourth zone. What is the fourth zone, students? Melting zone. Are you clear? So where is the melting zone will be there, students? See here, fourth zone is the melting zone. What is the fourth zone? Melting zone. Fourth one, melting zone. Okay, so what is melting zone, students? Where it is present in the furnace? Melting zone. So melting zone, nana, it is present just above the combustion zone. Are you clear? Just above the combustion zone, students. It is present. It is present just above the combustion zone. Are you clear? Just above the combustion zone, students. Combustion zone, just above the combustion zone. What is the temperature range, students, here? Temperature range is 1200 to 1500 degrees Celsius. This is the temperature range. Are you clear? So what is melting zone, students? It is present just above the combustion zone. Are you clear? It is present just above the combustion zone. So we know that here combustion zone, here see, Nana, here what are the zones we discussed here? 4 zones here. It is the lowest part of the zone. So lowest part of the zone, will call it as what we will call here, what we will call, students? Combustion zone. Correct? It is the combustion zone. Okay, it is the combustion zone. And uppermost part of the zone is calling as, it is the reduction zone. Are you clear? It is the reduction zone. And center part of the zone, this is the center part, students. This is the center part of the zone is calling as slag formation zone. Clear? Slag formation zone. Clear? And just above the combustion zone means this part is calling as melting zone. Are you clear? This is the melting zone. Are you clear, students? This is the melting zone. Okay, Nama. So now we are going to discuss the melting zone. So in the melting zone, what is happening, students, here? In melting zone, it is present just above the combustion zone. Here temperature range is 1200 to 1500 degrees Celsius. 1200 to 1500 degrees Celsius, Nana. Here in the which is on reduction zone. In the reduction zone, spongy iron is formed. Correct? So that spongy iron here, this it is melting, students, at 1300 degrees Celsius. That's why we are calling as a melting zone. Are you clear? That what is the formed, that spongy iron is formed in the which zone? Reduction zone. Are you clear? So in the reduction zone, Nana, spongy iron is formed. Correct? Spongy iron formed. So that spongy iron is melting, students. It is melts. Okay, melts at what temperature, students? 1300 degrees Celsius. At 1300 degrees Celsius, it is melting, students. So that's why this we are calling as melting zone. Are you clear? And it is collect at the bottom of the furnace, and it is collecting, melts at 1300 degrees Celsius, and it is collecting at the, and it is collecting at the bottom of the furnace. Are you clear? Bottom of the furnace. So that means we will get the here liquid melting iron we will get. Are you clear? That is, we'll call it as molten metal. Molten metal we will get. So from this one we will get the molten metal, Lana. It is the molten metal, students. Are you clear? So molten metal we will get. Now, already slag is formed. We know that slag is a lighter weight particle. So that's why these lighter weight particles, what are the slag particles are there? Those are float on the molten metal, students. See here in the diagram once. See, students, in the blast furnace diagram, this is the molten metal. See here, this is the molten metal, students. Molten metal. So that spongy iron is there, Nama. So that spongy iron is melt at 1300 degrees Celsius. This is the melting zone. That melted iron is settled down here. Are you clear? So at the bottom we can collect this molten metal, and here what is the slag formed here? Impurities. Those are lighter weight particles. So that's why here they are floating on the surface of the molten metal. So this is the molten slag, this is the molten metal, students. Are you understanding? See, this is the which one, students? This is the slag. Okay, this is the slag, students. Okay, so and this one is which one, Nana? This is this one is molten metal. Are you clear? This is the molten metal, this is the slag. This slag and molten metal both are removed from their respective holes. Are you clear? We can separate. Now we'll get the molten metal now. So we collected from the bottom of the furnace. So that molten metal we have to pass into the we have to introduce into the mold, students. Are you clear? So here what we got? Molten metal, Nana. Molten metal we got now. So that molten iron, when it is run into the molds, then it will become solidify, students. Are you clear? So this molten metal, here what is formed? Molten metal is formed, Nama. So it is collecting at the bottom of the furnace, students. Okay, now. So and the slag is, it is a lighter weight particle, slag. So what is slag, students? Slag is lighter weight particles, lighter weight particles, students. Hence lighter weight particles, hence those float on the surface of the molten metal. Are you clear? So now this molten metal and slag we can remove from their respective holes. Are you clear? So what I told you, students, here the slag and molten metal are removed from their respective holes. Clear, students? Respective holes we have to remove it. Then we got the molten metal now. So that molten metal, students, we have to molten metal, it is run into the mold, students. We have to pass into the molds. Students. So when passes into the mold, students, what will happen? This molten metal is converted into, when pass into the molten in molds, this molten metal is converted into, students, it is solidifies. Are you clear? It is solidifies. That means we will get the solid iron. So this solidifies, the solid iron solidifies, Nana. Here we will get the solid iron. This solid iron will call it as pig iron. Are you clear? This is calling as a pig iron, students. So this pig iron is impure form. It is impure form. It is a pig iron. It is an impure form, students. It is an impure form. Clear this one? It is impure form, students. In pig iron, Nana, carbon percentage is 4% will be there. How much percentage? 4% will be there. Here carbon percentage is 4% of carbon is present in the pig iron. Okay, na? It is impure form, students. It is impure form. So next, Nana, this pig iron again remelting, students. To this pig iron we have to add limestone. Yes, see, students, what we are adding? Pig iron. So what we are adding here? Pig iron plus limestone. Again we have to add limestone plus coke. Are you clear? So limestone and coke by remelting, students, again. Okay, so this charge again by remelting, what you will get? So remelting, we get which iron, students? Cast iron you will get. It is also impure form, students. It is also impure form. Okay, here how much percentage will be there, students? In the cast iron carbon percentage, 3 percentage of carbon is present. Are you clear? 3 percentage of carbon is present. After this cast iron, by the refining method, by the purification, you will get the, by the refining of cast iron, students, we will get the, by the refining of cast iron, we will get the wrought iron. Okay, we'll get wrought iron. It is having how much carbon percentage? How much percentage will be there, students? 0.5 percentage will be there. 0.5 percentage of carbon is present. It is the pure form. By using this steel items, so that all materials will prepare, students. Are you clear? That all, what are the tools are there, that all will prepare. Clear this one? Understanding, students? So by the here remelting again, by the remelting again, this mixture, students, pig iron, limestone and coke, you will get the cast iron. Are you clear? So this is the cast iron. It is impure form. It is a pig iron, students. It is a pig iron. It is impure form. It is also impure form. By the refining of cast iron, we'll get the wrought iron, students. Are you clear, Nana? So here total 4 zones are there, correct? Total 4 zones we have in the blast furnace. So what are the 4 zones, students? Combustion zone. So first, what are the methods, students? Here concentration method. Okay, now once you will see the diagram, Nana, see here, this is the cup and cone arrangement. Charge is introduced into the furnace. Here total 4 zones are there. This is the combustion zone. This is the uppermost, sorry, this is the lowest part of the furnace, combustion zone. Uppermost part of the furnace is the reduction zone. Center part of the zone is slag formation zone. Just above the combustion zone, we'll call it as, that is melting zone. These are the tires, and this is here any waste gases are there, impurities will go outside, and these are the tires. Here we are passing hot air. Here temperature range is 1600 to 250 degrees Celsius from bottom to top. This is the molten metal. Okay, Nama. So in the reduction zone, spongy iron is formed. That iron it is melted in the case of melting zone. So then we'll get the molten metal here. It is settled down. It will be it will be collected from the from the bottom of the furnace. And here what are the slag particles are there? Those are slag particles are lighter weight particles. So those are removed from their holes. Okay, Nama, we can remove that. That is the slag impurities are removed. Clear, students? And here see, Nana, these are the refractory bricks will be there. Refractory bricks here. Here refractory bricks will be there, students. This one refractory bricks here. And they will keep refractory bricks, Nana. What is refractory bricks, students? The materials which can withstand without becoming softening or without becoming melting. So those are calling as refractory materials at high temperatures. And understood, Nana? So that means the materials which can withstand at high temperatures without melting or softening. So those are calling as refractory materials. Examples we can take bricks. Here we are taking the bricks. Are you clear, students? So here concentration, calcination, smelting, roasting method, roasting, and after that smelting, that all we discussed. And after that blast furnace, total it is having 4 different zones. 4 zones. Combustion zone. Okay, now next reduction zone, next slag formation zone, next last zone is which one, students? Melting zone. So in the melting zone, what will happen, students? The spongy iron gets melted, Nana, at 1300 degrees Celsius. It becomes melt. Okay, now so here slag is a lighter weight particle, students. It is a lighter weight, lighter weight particles, so hence those float on the surface of the molten metal. Now the slag and molten metal are removed from their respective holes, students. Then molten metal will get, now this is passes into the molds. When passes into the molds, this molten metal is converted into solid state, students, solid iron, that is calling as pig iron. It is having the 4% of carbon. It is the impure form. We will get from this pig iron, this one pig iron plus limestone, and again add coke, limestone. Then again this mixture is by remelting will get the cast iron, students. It is also impure form. It is having the 3% of carbon. By the refining of cast iron, you will get the wrought iron. So it is used in the used for making the tools, students, steel items. Clear this one? I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, students. Thank you very much, students.